Yeah. Our objective for today, I can factor polynomials. Read together. 1, 2, 3. I can factor polynomials. Get a fair model going, please. So, in your Freyer model, in the center, you're going to write polynomials. Now, in the first quarter and in the first half of the second quarter, in our cumulative parties, I included definitions that you needed to memorize, right? Okay, let's see. Without looking at your notes, fill out your Freyer model. Remember that? The Freyer model? The boxes? Yes? So, polynomials, what is the definition for polynomials? Don't say it out loud. See if you remember. Polynomials are blah, 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 and blah, blah. Okay? Write examples, non-examples, and critical attributes. See if you remember. Write as much as you can, and then I'm going to show you the Freyer model that I have and see if you match any of those. I gave you guys some time for that. Okay, let's see. Polynomials. Here it goes. Polynomials are, let's see, monomials or sum and difference of monomials. Okay? So, yeah. Next, examples. Let's see. There they are. Non-examples and critical attributes. Fill out whatever you don't have filled out yet. Copy that. So, hands if you guys came close to that. Not bad, not bad. Okay, you guys remind me of me in kindergarten. Okay, here we go. Let's continue. Steps, write this down, please. Step 1, identify the greatest common factor. On these, you can abbreviate. Instead of writing greatest common factor, what can you write? GCF. Very good, GCF. So it says, identify the GCF, rewrite the polynomial using GCF and the remaining expression, and check your answer. Copy that, please. No, just kidding. I'm very nice to my brother. It says, identify the GCF for every term. Do we know how to do that? Yeah, we just did that right now, didn't we? Yeah. All right, rewrite the polynomial using the GCF and the remaining expression. We're going to do that right now, and we're going to check our answer. Here we go. So, to clarify some terms, you have space on the Q side. Is that correct? Yes, it's the Q. I want you to write factor and leave a space. And then underneath, you're going to write factoring. So, factors, leave a space for the definition. And then factoring, leave a space. So, even though they sound alike, they're two different terms. Factors means numerical and variable expressions that multiply. Factoring is the process of finding the factors of a number. Focus, Julia. So, if I was to write an example for factors using a numerical expression that multiply, I would use 2 times 3. Boom. That just happened. Is this a numerical expression? Is it multiplying? Yes, so that these two are factors. Bless you. Now let me show you a variable expression that is also that we can consider factors. Check this out. 2 parentheses 3x plus 1. 2 is a factor and 3x plus 1 is a factor. Why? What is the key word here? They are multiplying. Do you guys see that the 2 is multiplying right here? Yeah. That's why these 2 are factors. However, factoring, even though it sounds similar, factoring is the process of finding the factor. So, let's say I gave you the number 6. Think about one of the factors of number 6. What is one factor of number 6? Jonathan? 3. To find the other factor, check this out. 6 divided by 3 is 2. So my factors are 2 and 3. So what was the process that I did to find the other factor? That's why factoring is known as dividing. Now, hopefully now you're starting to put together the dots. First semester we did addition and subtraction of polynomials, right? We did multiplication of polynomials, and guess what was missing? Division. That's why we're coming back, but now they call it factoring. You understand? Why? Because we're going to find what? The factors of polynomials. Everybody got it? All right. Example 1A. Copy this down. Factor each polynomial and check your answer. Factor each polynomial and check your answer. We got 2x squared minus 4. Copy that, please. All right, here we go. Let me zoom in. Pens down, eyes up here. Here we go. I'm going to factor this polynomial, and so that you can see why last night's home play was important to look up. Because now, last night I gave you different monomials, right? So imagine I gave you this monomial and this monomial, right? But today I'm putting them together, so it becomes a what? A binomial. But it's the same process. Let's find the GCF. What is the greatest number that divides 2 that divides negative 4? 2. And instead of me just labeling, you're just paying attention right now. Instead of me just saying GCF is 2 and then finding something else, I'm going to leave it like that, and I'm going to open a parenthesis. Why? Because what is the process for today? We're finding the what? Factors, which is factoring. Therefore, 2 divided by 2 is 1. What do we have left? X squared. Negative 4 divided by 2, that's negative 2. And these are my factors. Copy that, please. All right. However, this says what? Check. To check, right? And how do we check? Check this out. You distribute. 2 times x squared, that is 2x squared. 2 times negative 2, that's negative 4. Did we get the same thing that we started with? Yes, that is correct. Now check this out. At this point, for those of you that did not practice last night your GCF and LCM, right now you're just hearing this. Blah, 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 blah. 2x squared minus 4. That's all you're hearing. Therefore, for those of you that did not do that, let me show you an easy way of seeing this in a different way. Look up, please. Here he goes. First semester, I remember when we got to rules of exponents, I said, when in doubt, factor out. So I'm going to factor this first term. This becomes 2 times x times x. And I could put this one times 1. Yes, thank you. This one becomes negative 1 times 2 times 2. Is that correct? All right. Therefore, what do both of these have in common? The 2. What do we have left? 1 times x, that's x squared. Negative 1 times 2, that's negative 2. Therefore, when in doubt, factor out. Here we got it? So once again, if you didn't see it here, copy this and just put a little asterisk so that you can factor out some of the rest of them so you can see what we're doing. Okay? Of course it's easy because you see it. No, because it's faster. But some people don't see it. Do you see? Be nice. All right, everybody got this? Example 1B. Once again, for this next one, you don't copy the instructions, just copy the polynomial. Negative 14x minus 12x squared. Let's do this one together. All right, once again, what number divides negative 14 and negative 12, the biggest number they can think of? 2, but both of them have a what? So therefore it's negative 2. Do both terms have an x? Yeah, so you write x, and let's see what we have left. Negative 14 divided by negative 2, that's 7, positive. X divided by x is 1, and 1 times 7 is 7, so we leave it at 7. Does everybody see that? All right. Negative 12 divided by negative 2, that's positive 6. X squared divided by x, x. And those of you that don't see what we're talking about, here it goes again. X squared divided by x. What is the rule? So therefore we're left with and to check, once again, distribute, let's see. This is negative 14x, and this is negative 12x squared. Did we end up with what we started? Yes. How we doing? Yes. The what? Hey, we'll get there. Bam, good question. Yeah. Hey, that's a good idea. Thank you, Santi. Let's continue. Example 1C. See if you can do this one by yourself. Here we go. Example 1C, 8x cubed minus 4x squared minus 16x. Find me the factors, please. And if you notice, instead of being 2 terms, now it's 3 terms. So it's the same process. See how you do with that one. Go. All right. So step 1 was to factor out the GCF. Who has the GCF already?
I do.
Okay. Chris V. What'd you get? 4x. Hands if you got 4x. That is correct. From there, you open your parentheses and you go 1 term at a time and do your division. Yes? Therefore, 8x cubed. Let's see. 8 divided by 4, that's 2. X cubed divided by x is x squared. Second term, negative 4 divided by 4, that's negative 1. X squared divided by x is x. That's fine. Negative x, that's fine. Negative 16 divided by 4, that's negative 4. X divided by x is 1. 1 times negative 4 is negative 4. Therefore, these are my factors. Hands if you got that. Okay? Not F. I want you to write factors for right now. Because guess what? Some of you still hear me say factors and you still don't know what the factors are. Watch. Think about this. If I was to ask you, what are my factors in this expression? Yes? No, because this one does not have a negative. They all need to have a negative. So what are my factors here, Santi? What is it? Oh. Okay. Faith. Oh, my bad. Caitlin. Be nice. Okay. Here are the factors. This is one factor, and this is a second factor. Why are they factors? Because they're doing what here? Multiplying. Factor number 1, factor number 2. Label that, please, so that you won't forget. That's why we're going through the process of factoring, because we're finding our factors. Do another one. Copy this one, example 1D. This one has a little curveball. See if you catch it. Go. You have 15 seconds. 3x cubed plus 2x squared minus 10. No decimals. Nope. Let's go.
Let's go.
No, it's not no solution. All right, let's see. Can you give me the factors, please? Patrick. Okay. What would you say your GCF is?
1.
Hands if you got 1 for your GCF. That is correct. So my other factor is 3x cubed plus 2x squared. Wow. These are my factors. All right. Continue. Example 1E. Go ahead, copy this one. Hurry up, hurry up, hurry up. 8x to the 4th plus 4x cubed minus 2x squared. Find me the factors. Example 1E. You have 15 seconds. Go. I know. All right, check with the neighbors, see what they got. Okay. Let's see. Give me your factors, please. Go ahead, Sergio.
2x parentheses 4x squared. Oh, my bad. Cube. The first one, 4x to the cube.
Hold on. Let him finish.
All right. Minus x. Minus 1x.
All right. Hands if you agree with that. Okay. Hands if you got something else for the GCF. Let's see. Chris R., what'd you get for GCF? 2x squared. Remember, it's the G greatest common factor. So what was the greatest one we can extract from each term? X squared. No. The correct simplification, look up please, is 4x squared plus 2x minus 1. Okay, hold on. Guys, we need one more. I am waiting for you guys. So these are my factors. Now check this one out. Look up. You're welcome. It says, the area of a court of a game of squash is 9x squared plus 6x. Factor this polynomial to find the possible expressions to the dimensions of the squash court. So check this out. Just draw a rectangle for the squash court. And what is the area of the court? 9x squared plus 6x. Be careful with these that and start including measurements, because some of you start thinking that this is a variable. It's not a variable. It's meters squared. Because that's what we're going to find. We're going to find the factors. So what is my GCF, everyone? 3x. Therefore, 9x squared divided by 3x is 3x plus 2. So the dimensions of the court are 3x times 3x plus 2 meters. Meter squared is for the area. This is not the area yet. They're barely going to multiply. Everybody with me? Once again, home plate for tonight. Some pages, what is it? 523 to 525, all, and page 529, numbers 1 through 7. Have a good one, guys. To your home plate. See you guys tomorrow.